Hey y'all, here's a fun geometry problem. It says that the triangle and the hexagon are both regular polygons and they have the same perimeter. We have to find the ratio of the areas of the circles. Let's start by labeling the area of the first circle A1 and the area of the second circle A2. We can also label the radius of the first circle R1 and the radius of the second circle R2. We need to find the ratio of the two circles. That's going to be A1 over A2. The area for a circle is pi r squared, so that's going to be pi times r1 squared over pi times r2 squared. And notice that the pi's cancel, so we're left with just r1 squared over r2 squared. That'll tell us the ratio of the area of the two circles. That's important, so let's move it over here and put it in a box for later. Now let's label the sides of the polygons. We'll use T for triangle and H for hexagon. And since they're regular polygons, all of the sides of the triangle are going to be T and all of the sides of the hexagon are going to be H. And since they both have the same perimeter, 3T is going to be 6H. That's because a triangle has 3 sides and the hexagon has 6 sides. We can divide both sides by 3 to get T equals 2H. Let's replace this T with 2H. Now let's take a closer look at the triangle. First thing I notice is we're going to have a right angle here. Now let's draw the angle bisector from here to here. Since the angles in a regular triangle are always 60 degrees, half of that is going to be 30 degrees. And since the angles in a triangle always add up to 180 degrees, and 30 plus 90 is 120, that leaves 60 degrees for this last angle. This is a 30, 60, 90 right triangle. And since this whole length is 2h, half of that length is just going to be h. So our short leg is r1 and our long leg is h. In a 30, 60, 90 right triangle, the ratio of the short leg to the long leg is always 1 over root 3. And since the short leg is r1 and the long leg is h, 1 over root 3 is going to equal r1 over h. Let's move these over here, flip them around, and solve for r1. We're going to solve for r1 by multiplying both sides by h. Over here, the h's cancel, so we're going to be left with just r1, and 1 over 3 times h is h over the square root of 3. So r1 is h over the square root of 3. Let's move that over here and save it for later. Now let's look at the hexagon. We're going to start by drawing the angle bisector right here. Now we have a smaller triangle. First thing we notice is we have a 90-degree angle right here. And since this line segment cuts this angle in half, we need to find out what half of this whole angle is. In a regular hexagon, the angles are always 120 degrees. So half of that is going to be 60 degrees. And since the angles in a triangle always add up to 180 degrees, and 60 plus 90 is 150, that leaves 30 degrees for this last one. This is another 30-60 right triangle. And since this whole length is h, half of that is going to be h over 2. We can now find r2 using the same method as last time. The ratio of the short leg to the long leg is 1 over the square root of 3, which is going to be h over 2 all over r2. Let's move these over here and solve for r2. We can solve for r2 by cross multiplying. r2 times 1 is just r2, and the square root of 3 times h over 2 is the square root of 3 times h all over 2. So r2 is the square root of 3 times h over 2. Let's put that in a box and move it up here for later. Now that we know what r1 and r2 are, we can solve for r1 squared over r2 squared. We're going to do that by substituting what we found for r1 and r2. So r1 over r2 squared is going to be equal to h over the square root of 3 all squared, all divided by the square root of 3h over 2 all squared. On the top, that's going to simplify to h squared over 3, and on the bottom, it's going to simplify to 3h squared over 4. Let's move that over here. Since dividing by a fraction is the same as multiplying the reciprocal, we're going to rewrite this as h squared over 3 times 4 over 3h squared. And we have to figure out what that's equal to. First thing I notice is that the h squareds are both going to cancel. That leaves a 4 on top, and on the bottom we have 3 times 3, which is 9. So r1 squared over r2 squared is 4 over 9, and that is going to be the ratio of the first circle to the second circle. Pretty cool stuff.